Hi, I am Raju from NICER, and I'll be presenting a poster on the is algebra and the theories that are invariant under the is algebra. So before going into the algebra, uh, let me tell you about the celestial holography. It's a duality between a quantum theory of gravity in 3 plus 1D asymptotically flat spacetime and a 2D celestial CFP that lives on the celestial sphere at null infinity. So celestial amplitudes, or the celestial correlation functions, are obtained by doing the Mellin transform of the momentum space S matrix. And in the celestial holography framework, it was shown that the holographic symmetry algebra for gravity is wedge subalgebra of W1 plus infinity, and for the gluons, the algebra is the S algebra. So what is this algebra? This algebra is basically obtained by from the singular part of the OP between two positive helicity outgoing gluon primary operators on the celestial sphere. And as you can see, because of the presence of this beta function, one can define the infinite tower of soft gluons and the modes of which basically construct this S algebra. Okay, so in my poster, what I would show is that there actually exists an infinite number of theories or infinite number of OPs that are invariant under the S algebra, and we'll also find the KZ type null states of these theories. Okay, so the most general form of the OP can be this one. This first part is a singular part of the OP, and there could appear the descendants from the S algebra at a particular order, right? So our task could also be to determine the coefficients and the descendants that could appear, descendants of the S algebra that could appear at order 1. Okay, so and we also know that tree-level MHB sector is one of the S invariant theories. So using this MHB sector OP as a basis, we can write down the OP of any S invariant theory in terms of the OP of the MHB sector and the null states of the MHB sector. Okay, so our main result would be to determine S invariant OP for any theory in terms of the MHB OP plus null states of the MHB sector. And if you look carefully in this expression 18, that the number of null states that appear in the OP of a theory, that is not actually fixed by the S invariance. So different values of this n would give you different theories or different OPs, which would correspond to different theories. So for n equals 0, it is the trivial one, that is the MHB sector of the P-O Yang-Mills theory. And for n equals 1, we have explicitly checked that it is the self-dual Yang-Mills theory in the bulk side. But for n equals 2 and beyond, we don't know what these theories actually correspond to in the bulk side. So this is an open problem. We also find the KZ type null states of all such infinite number of theories, and these null states put strong constraints on the celestial amplitudes of the corresponding theories. So this null state would be very useful in search for the bulk theories corresponding to the n equals 2 and beyond. Yeah, so this is the brief idea what I'll be presenting in my poster. So if you are interested, feel free to join during the poster session. Yeah, I'd be happy to meet you. Thank you.